Hello everybody, let's have a second part of logistic regression, binary logistic regression, where we have practical demonstrations through our program. Okay, so how this actually works by using codes, I will try to explain. Okay, I'll align the previous theory and work on this concept. Okay, go ahead. Let's go ahead. Okay, binary logistic regression, right? We have simple binary logistic regression, then we have multivariable binary logistic regression. Okay, we have two. So let's work simple first, then we'll dive into the multiple. Okay, suppose we have a bank loan data sets. Especially in our program, if we give table and bank loan, right? Bank loan, table, bank loan, dollar, right? Default. This will print, right? Who defaulted means paid. Suppose default 1 and no default is 0, right? Consider default. Who defaulted the loan as 1 and who not defaulted the loan, that loan is 0, right? So suppose we have bank loan data sets, we have lots of columns, rows, data sets. Inside that data set there is a column called default column. There it is categorized in two parts, 1 and 0, right? First, dependent variable must be coded with 0 and 1. First assumption in binary logistic regression, right? So now it is satisfied that first condition. So default has a 2, 1 and 0. So then this I am considering as a dependent variable. So our model is log reg. Let me consider log reg 1 equals to GLM. Okay, in binary logistic regression we will use GLM, not LM. GLM means binary logistic regression. Okay, so GLM, we keep this default variable as it is. Then we use tilde. I am comparing that based on the person age. Is there is difference in default loan, right? They defaulted or not? Maybe based on the age group, whether they paid loan or not paid. That's a thing we are trying to see here, right? So this is dependent variable, and I will consider independent variable as age. Now what happened? Now we need to call this family equals to binomial. In binomial, what we do? We have to link, right? Link what logic, right? Means logistic regression. Then data sets. What is the data set? Data equals to which data sets we are working on? Bank loan. So bank loan. So from bank loan data sets we are extracting two columns. One is default, one is default itself in a binary, right? I mean to say 0 and 1, and this age is a maybe continuous variable, continuous or maybe categorical independent variable. Okay, so this is dependent variable, this is independent variable, that may be in a continuous or categorical. Okay, so when we do summary, right? Summary log reg 1, if you find that significance, so this is what we do in first step. In second step, what we do, In second step, right, maybe some significant value will come, or maybe based on the age, right, loan may have defaulted, those kind of summary will come. Then if you move ahead after that, right, if you found significant, then if you move ahead, move in a second stage, what we do, we have a second, that R square, we have to look at it, right. How will we look at it? McFadden R square, MC Fadden R square, we look at it in second stage. How? Suppose R square is equals to, we have a formula 1 minus what? 1 minus this model, okay? We have to call this log rate 1 here. So log rate $1, then what? Log rate $1 deviation we need to call, okay? Deviation divide by what? Again log rate $1 then null deviation, okay? So we have to call null deviation. So when we print MC Fadden McFadden.R square, we might get some percentage, right? 0.003 if I got, means this is ultimately converted in percentage, and 3% it's captured by age. 3% variance is captured by age. We can interpret like this, okay? 3% variance is captured by. And there is one more thing we need to do, this binary logistic regression, right? In simple binary logistic regression, in third step, we should work on omnibus chi-square, okay? To work on omnibus chi-square, first of all, let's make a null model, okay? For null model, to compare those things. So for null model, same thing, I need to say log rate 0 equals to, log rate 0 equals to, what happens? We call omnibus chi-square, right? Log rate 0 equals to, same thing, GLM default tilde what? Default tilde what we do here? Default tilde 1, right? 1 means we are comparing to null. So same thing here, family equals to binomial link, right? We need to call link equals to logit, and data equals to what? Data equals to what? Data equals to bank data, right? Bank data. So we are making log rate 0, which is null model, and there is log rate 1 is another model. So for omnibus chi-square ANOVA, we need to look for ANOVA table. To look ANOVA, we call ANOVA, right? Then log rate 0, comma log rate 1, comma test. What test? Omnibus chi-square. Q, right? Omnibus chi-square test we do. Then if we found it, the value is significant, means this can be taken into the final model, right? Suppose, let's compare with age. What about education, right? For educations, we have compared for only age, right? For education, what we do? Log rate 2, same thing, GLM default tilde, right? Factor we should use for education because it is categorical, right? And same thing, family, same column, family equals to binomial, right? Link equals to logit, right? Then data equals to what? I don't know what just happened to the projector. Okay, so data equals to bank loan, right? Bank loan data. So you can look, we have taken another variable in our ANOVA. What we do here, again we call ANOVA to check omnibus chi-square ANOVA, then log reg 0 comma log reg 1, right? And test ACHISQ chi-square test, right? So if we found significant, then we can take both model, right? Both variables can be accepted for final model, and we are not going to interpret this value. Okay, if we do this value is not, we are not going to interpret, because these values are in that odd the y odd of odd value, something we already learned in previous, right? Some odd of y, some values. So we need to for that we are not going to interpret that value. We will use library. We will call library car, right? Then we use margin function for log reg 1, margin function for log reg 2. Okay, so we will see that and compare the result. Ultimately result will be compared through margin, right? We have to import, we have to call that library car, then we call that function margin, in margin log reg 1, margin log reg 2, and that those results will be interpreted. Okay, for multiple, when simple is done, right? For multiple, what will do? Multiple multivariable binary logistic regression, right? Multivariable binary logistic regression. Multivariable binary logistic regression. What it is? For linear regression, if you remember that VIF is less than 10, means you have to accept and paste those values to the model, right? Here we have to less than 2 VIF. We need to check VIF here. Okay, VIF less than, I mean to say VIF less than 2. Keep. Okay, first major important thing is to check VIF for variables, right? Check VIF, and VIF is less than 2, then keep this for the model, and other parts are the same. Suppose we know default variable, right? Suppose I call log reg 4. Okay, I call log reg 4. Then what happened? GLM, okay, default tilde, right, is plus factor, we know edu, right, plus variable n. Maybe there are a lot of variables, right? You add it, and ultimately what you do, family equals to binomial equals to what? Binomial family equals to binomial link logit, right? Link logit. So family binomial link logit. Then data equals to what? Data equals to bank loan, right? So what we do? This will print all the things, but we need to check VIF, right? For that you call library car, then check VIF of this model. log reg 4. Okay, you check DIR. Then if you find, you will check DIR of log reg, DIR log reg 4, right? You will check DIR of log reg, and if you find some variable are crossing the set standards greater than less than 2, right? Suppose education, maybe we call income variable has 3.12 dir. Okay, suppose 3.12. Then again we have to fit model log reg 5, then same thing glm default, right, tilde is plus factor edu, right, plus add plus you should not consider these variables over here. Okay, this income variable over here, and just call by family equals to binomial equals to what? Family equals to binomial family equals to binomial. Here link equals to logit link equals to logit, family equals to binomial, link equals to logit, and data equals to bank loan. Okay, so now it is fine. So now again you check DIF log reg 5, and you found all the DIF are less than 2. DIF, you found all the DIF less than 2. So you will take all the variables and developed the these things, developed the model, and worked like same we did in this one, simple linear regression, right? Here you already know that we will first do the model, right? Here we have only did x, right? We need to add other variable also. We'll add it other variable, lot of variable along with that. Then again we'll check McFadden R squares, right? Deviation 1 minus log rate 1 dollar deviation divided by log rate 1 null deviation. Then we'll interpret that value, and omnibus chi-square we make first null model, right? By keeping 1 only. Then we will compare this with ANOVA, right? We will compare with log rate 0 and log rate 1. Okay, log rate 1 means 1 by 1 it is comparing over here, right? So likewise we should accomplish the simple basic way of understanding this binary logistic regression. Thank you.